Today we're going to use logs to solve equations. Use logs to solve equations. So it's finally an answer to like, why did we need to know this, right? Well, we already knew how to solve exponential equations when it works out. Like we know that 2 squared is 4 and 2 cubed is 8. But if we said like 2 to what power gives you 6, I don't know. Now I gave a little graphical solution, like maybe you could graph on your calculator y equals 2 to the x and kind of see when does, what ordered pair of x corresponds to a y coordinate of 6. Now you can't plug in y coordinates, so you're kind of using your trace and guessing and checking, and I've done this before and it turns out about to be 2.6, but is it really 2.6? Like we really don't know. So here's how to solve them. I wrote the steps down for you. You're going to first see if you can write both sides as powers of the same base. So if it's, one you're good. But if not, what we're going to do is take the log of both sides. The log of 2 to the x equals the log of 27. And the third rule of logs says that the x can come down in front. X times log 2 equals log 27. And then you're going to divide both sides by log 2. Now you can't cancel that out or anything. You would just literally type that in your calculator, log 27 divided by log of 2, and we're going to round this to 3 places after the decimal, 4.755. Now it can get a little bit tougher when you have an expression in the exponent. So here when I take the log of both sides, and I'm just taking that right down in front, is equal to the log of 35. Now I'm going to give you a present, and it's a really good present, and you're not going to get that present next year, but for now I am going to allow you to have a decimal within an equation. It's typically not allowed. Typically we would have distributed that and simplified it, but here we're going to divide on our calculator log 35 divided by log 3. We're going to get this big 3.236 number. And then all I need to do is subtract 1 from both sides, 2.236. It's just going to make our lives a little bit easier, even though the problems are still kind of tough. Like this one, x plus 1 times log 3 equals x times log 2. That's not totally simple, right? And I'm going to allow it to divide both sides by log 3, but even here you're going to have to remember that you've got an x on both sides. So on my calculator here, I'm just typing in log of 2 divided by log of 3, and that's turning out to be 0.631. So x plus 1 equals 0.631x, right? There's still an x there. So if I subtract 1x from both sides, here I'm going to get 1 equals negative 0.369x. So I'm going to have to divide that out and get an answer of negative 2.7, it's actually 2.710 there, 2.710. So you got to be a little careful with that one with x's on both sides. So I have another one with x's on both sides just to practice. So here when we take the log of both sides, the 3x plus 1 comes down in front. The 2x plus 1 comes down in front. We're going to have a lot of decimals here. I'm going to get rid of this log 6 by dividing both sides by log 6. So I have log 8 divided by log 6. 1.161. So 3x plus 1 equals 2x plus 1 times 1.161. And that's going to have to get distributed. 3x plus 1 equals, if I multiply that by 2, 2.322, right? Hang on. Yeah, 2.322 x plus 1.161. So I've got like numbers on one side, x is on one side, whatever. So I got to like move that over. subtract the 2.322x from both sides, and I'm going to get 0.678x equals 0.161. So it's usually not our style to have so many decimals, right? And really, it's still an approximate answer, 0.237. But we are going to allow that this year. Next year, you'll have to do a more exact answer. The last one here, number 5, has an E. And so when we have an E, we're going to use, instead of the log of both sides, we're going to use the natural log of both sides. Why? Well, I'm going to get a little present here. The natural log of E. What do you think the natural log of E is? Remember, the natural log is log base E. So e to what power gives you E? Yes, 1. So natural log of E is just 1. So I have x minus 1 times 1 equals the natural log of 24. So I can just type in my calculator, natural log of 24 is 3.178. Add 1 to both sides, 4.178. Some people will ask, how do I know if I take the natural log? If it's an E problem, you're going to want to take the natural log. You could take the log of both sides, you'd get the right answer, it would be no problem. Natural log just makes it easier. Okay, another kind of outdated, I call it hashtag throwback TBT definition called the change of base theorem. Now, our new calculators give us log base 5 of 10 for us, but the log base 5 of 10, if I use this as a model, can be written as the log of 10 over the log of 5. And for right now, I don't even need you to type that in the calculator and get that decimal. I just want you to know that those are equivalent answers, log 16 over log 3. You might say, why? Why is that the same? So let's just take number 7 as an example. If I have the log base 3 of 16, if I set that equal to x, I could log loop it, 3 to the x equals 16. I could take the log of both sides, and the x comes down in front. X log 3 equals log 16, and divide both sides by log 3. The last ones here are reminiscent of days gone by when we factored what we called quadratic-ish equations. And so we have to factor these quote-unquote, well, they're not quote-unquote, they are log equations, but they factor just like we used to do, where you take that middle variable and that goes on each side, so log x equals 3 and log x equals 2. And then remember, log is understood to be base 10, of course, so 10 cubed is x, or 10 squared is x. So we get two answers, either 1,000 or 100. Similarly with number 9, e to the x is going to be what goes in each parentheses. Now I need two numbers that multiply to 14 and add to negative 9. So here I get e to the x, if I jump ahead, is going to equal 2, and e to the x is going to be 7. It's easiest, I think, to rewrite this as a log. It's the log base e of 2 equals x. The log base e of 7 equals x. And log base e is natural log. So all I have to do is type in the natural log of 2, which is 0.693, and the natural log of 7, which is 1.946. If you want, you could use substitution for those. I call it stone cold factor. I just think it's a little bit less work, but if substitution is more your thing, you could definitely use substitution, using logs to solve equations.